sharing. Yeah.
Okay. Okay. Can you see the screen?
Yes.
Yes.
Okay. Should I start now? Or?
Okay, please go ahead.
Okay. Hi everyone. My name is Yuxin, and first I just want to thank the organizer for giving me this opportunity to talk about my ongoing project on this very active Fast Radioverse 2020-1124A. So FRBs, as we know, are notoriously mysterious in the sense that we don't really know where they're coming from. And one of the primary approach to gain insight into their unknown origin is through the study of their host environment, which Shivani had talked about in a previous session. And there are two sort of scales we can probe. One is on a more global scale, in which a lot of the FRBs have been localized to their host environment. And this very robust association has helped us identify the host morphology and deriving the stellar population properties, which then tells us a lot about the kind of stars that live within and around the FRB. And the diagram is showing some examples of that. Another way is to look at it more locally, so subgalactic scales, which has helped us uncover counterparts to FRBs, including the persistent radio sources that are connected to two of the FRBs we know. It has also helped us probe the very diverse local environments with the prominent examples of 2001-20E that was found in a globular cluster, and 121102 and other FRBs found in the star-forming regions of their host environment. So as alluded to in the previous slide, there are two very peculiar FRBs that are linked to a persistent radio source, or a PRS. So these two are 121102A and 2019-0520B. They're both found in dwarf galaxies, which is quite unusual compared to the rest of the FRB population. And they are known to repeat based on observations. And what makes them really unique is the fact that they're connected or co-located with this persistent radio source, which is a type of incoherent isotropic synchrotron emission. And what I mean by persistent is that the flux doesn't vary with time very much. So because they are the only two FRB PRS pairs, they are definitely on the more rare side. So now I'm going to introduce the hyperactive FRB 2020-1124A. The plot is showing the number of bursts detected in the observing windows from Xu et al. 2022 using the 500-meter aperture spherical telescope, or FAST. They observed a grand total of 1,800 bursts in 82 hours. So it's definitely super active. And it lives in this barred spiral host galaxy that's relatively nearby at a redshift of about 0.1. And as far as we know, it's the most active FRB, which has garnered a lot of interest from the community as to what is causing such a hyper extreme activity from this FRB. So just to put a face to the name, this is a HST image from our new program in the infrared of the barred spiral galaxy that I had previously mentioned. So we see that the bar structures extend from the nucleus with the spiral arms winding and connected to the bars. The host center is marked as this blue cross, and then the FRB localization from the European VLBI network, or EVN, is marked in this yellow star. We'll revisit this a little bit later. And so fortunately, we do have broadband data for this host galaxy. Shown here is the spectral energy distribution, or the SED, of the data, with the flux on the y-axis as a function of the frequency. So UGMRT and VLA have reported persistent radio emission from the host galaxy. And so in Fong et al. 2021, they set out to answer the question of what's causing this persistent radio emission. So they compared the multi-wavelength observations to radio loud and radio quiet AGN templates because we know that AGNs can be very prominent contributors of radio emission within galaxies. And we see that the data does not seem to agree with the model very well. However, if we fit the data to this star-forming galaxy using a non-parametric model from Prospector, which is a package that specializes in stellar population modeling, we do see a very broad agreement between the data and the model. So from there, the conclusion is that the radio emission that we see from the galaxy can be attributed to star formation, which now joins two other FRBs. I think they're both non-repeaters that have radio emission in their host galaxy that can be attributed to star formation. And so what's more interesting is that Pirro et al. 2021 had presented high frequency, very large array, or the VLA observations of this extended radio emission very close to the burst site. So this is at 22 gigahertz. Again, the EBN is plotted as a yellow cross, as well as the half-light radius of the galaxy from SDSS. So we see this extended radio emission, and the result from that is that it's connected to some sort of enhanced star formation activity that's very close to the EBN, which really prompt us to investigate the connection between this FRB with any sort of underlying enhancement of star formation. And I personally think the shape looks like an upside down papaya, but maybe that's up for debate. So we obtained very deep VLA observations in A configuration, which is the highest resolution available through the VLA, mainly to answer two questions. One is whether this FRB is related to any sort of enhancement of star formation on a more local scale, and whether it's associated or co-located with a potential PRS. And if it does exist, it would be the faintest PRS we have to date. So here is the new deep radio observation that we reduced in image. This is in C-band at a central frequency of 6 gigahertz. What's shown is the host center as the blue cross, and then the outlines are the contours at different significance levels, with the higher significance level towards the center. And then we add in the very precise FRB localization from EBN and the ASCAP localization, which is the first interferometric localization for this FRB. And then also on top of that, the high frequency contour from Pirro et al. 2021. So what I want to point out here is that the morphology from our observation is different compared to the high frequency contours. But we do see that this small blob is consistent with the significance levels at the higher frequencies. But because of this extended emission, we don't see any apparent PRS that's co-located with this FRB, just because it doesn't seem to be compact at a 6 sigma significance level. But nevertheless, we can still place very meaningful constraint on its luminosity and also the size of a potential PRS. So with the radio observations we have, we can also plot the SED, again with the flux on the y-axis as a function of the frequency. We just fitted the observation with a simple power law, and the spectral index came out to be 0.7. Which is actually what you would expect for star formation, and it usually ranges between 0.7 to 0.75. And this indicates that maybe there is some ongoing star formation within the host galaxy. So in the context of host environments, I do want to quickly compare this to other FRBs that have been localized to their environments. So the examples are 2019-06-08, which is non-repeater, and 2018-09-16B, which is a repeater. And what I want to point out is that the FRB locations marked in this red circle and the black box on the right are both located on the spiral arms of their host galaxy. So now if we compare it to our new HST observation of this host galaxy for FRB201124A, we see that the FRB seems to be offset from the bar structure, but also away from the spiral arms. And that really goes back to the title of this talk, thank you, of this talk, where with such an extreme activity from the FRB, we would definitely expect it to be at a location where most of the action is happening, but it just doesn't seem like that's the case. It seems to be in a surprisingly quiet local environment. But if we plot the radio contour from our C-band image and the high frequency contours, we do see that there's some sort of emission there in the radio, even though it doesn't seem like the FRB is co-located with any sort of elevated star-forming region. So this diverging picture that optical and radio observations are painting points to dust obscuration, in which the star formation could be obscured by dust within the host environment, such that we don't see it in the optical, but we do see it in the radio. And lastly, I just want to mention that Alexa Gordon from my group has recently submitted a paper on the host galaxy studies of FRB population. And she has a star formation history of this host, which is star formation rate as a function of the look back time. And it seems like it's a rising star formation history with some sort of plateau towards the recent years. But nevertheless, it does also support the fact that there could be some recent ongoing star formation there. So with that, I'll just summarize that we don't really see any apparent PRS based on our observation at the sensitivity we're probing, and there could be some obscured star formation within the host, which could lead to implications for the progenitor system of this FRB. And with that, I'm open to any questions.
Thank you very much, Yuxin. Questions and comments, please? Tete-san.
Thank you very much for a very nice talk. So I have a question about this dust occlusion. So you showed the star formation history actually. So therefore, I guess you did a SED fitting to derive the star formation history. At that time, probably you can also derive the dust extinction of the host galaxy, I guess. And then my question is, you have now very high spatial resolution image of HST. So therefore, I just wonder if you can try to derive dust extinction map on the host galaxy to see if the dust extinction is really high around the location of the FRB to prove your hypothesis.
Yeah, that's a great point. And actually, the non-parametric fitting of this host galaxy has shown that it is a very dusty galaxy. So yeah, we already know just based on SED fitting that this is a very dusty galaxy. So I guess it kind of supports our hypothesis that there could be some sort of dust obscuration. Yes.
Yeah, thank you very much. But my point is spatial distribution of this dust extinction. So I think I thought you are saying that at the position of FRB, dust extinction might be important there. So therefore, at that location, you may be able to find the dust extinction higher at that position.
I see. You mean like on a more local level? That
Yes. Yeah, I was wondering if it's possible using Hubble spatial spot data.
Yeah, I'm not sure, but I think that is a good point, and I will definitely think about it a little bit more, and then I can get back.
I see. Thank you very much. Thank you very much.
Thank you very much.
Okay, online question?
Online question from Curtin University. I think that's Clancy James.
No, it's actually Marcin Blavatsky sitting next to Clancy James. Thank you for the nice talk. Just related to obscured star formation, I was wondering if you considered the Wise magnitudes, for example, because the mid-infrared bands could also give you an estimate of obscured star formation in the host galaxy.
Oh, right. Right. So from the WISE data that we have, maybe that could also give us an indication whether there's dust obscuration.
Yes, and you can also make an estimate of the star formation from the WISE magnitudes.
Oh, okay. I see. Yes.
Specifically obscured.
I see. I have not considered that, but yes. Thank you for that.
Okay.
Right.
Okay. Okay. So the time is up. So let's thank Yuxin again.